Welcome to Technovation. I'm your host, Peter High. I'm pleased to welcome Lama Nachman to the broadcast. Lama is an Intel Fellow and the Director of Intelligent Systems Research Lab at Intel. She's been with the company for most of the past 2 decades. I look forward to hearing more about the mission of her lab, the groundbreaking work she and her colleagues are undertaking, her thoughts on the future of artificial intelligence, the role it plays in concert with humans, and a variety of other topics. Lama, welcome. It's great to see you today.
Thank you. It's wonderful to be here.
Well, Lama, I thought we'd begin with your lab. I mentioned a moment ago, you're the director of the Intelligence Systems Research Lab. Talk a bit about the mission of the lab itself, if you would.
Sure. So our lab is actually a multidisciplinary research lab. So we span social science, design, and AI research. And what we're really trying to do is understand what are really kind of the unmet needs when we think about where AI can actually play into the world. How could it help amplify human potential? How could it support people in performing all sorts of tasks? And then think about what is needed from these AI systems to go and deliver that type of support. A lot of the work that we do really focuses on human AI collaboration. So what we're really trying to do is essentially bring humans and AI together so that we could improve AI and B, amplify human potential. But we also solve some, really kind of basic challenges in AI to try to improve the way that it learns, to learn in really large scale networks, to learn from very limited data, which are all kind of problems that AI systems have today. So essentially, we kind of look at it all the way from the human need and go all the way down to understand what needs to happen from an AI innovation perspective to bring that to real life.
That's a great overview. Thank you for that. You mentioned that it is a multidisciplinary lab. Talk a bit about the sorts of skills you bring together that are necessary to do the groundbreaking work that you just described.
Right. So in most of the work that we do, we start with really trying to understand how people actually function in all sorts of different areas, right? So for example, if we're thinking about something like manufacturing and how AI can play a role, we would have social scientists and designers who go and spend a lot of time with people who perform tasks in these settings and try to understand what are their workflows, right? What are these unmet needs and how can AI kind of play into these existing ecosystems, right? We do the same thing in like education, early childhood learning, things like that. So we always start with the human element. And then from there, ask the question of, how can we make that experience better? And where can AI come in to actually then solve some of these challenges and problems?
And talk a bit about, if you would, Lama, there have been such remarkable progress made in recent years relative to artificial intelligence. Where we are today, where are those limitations? What is it doing effectively that humans once did, or perhaps even still do, but are ripe for replacement by artificial intelligence? And where is sort of the next frontier? Where are we humans, at least for the time being, and perhaps for the foreseeable future? What are the sorts of things that we're better at as the complement to that?
Yeah. So if you think about maybe what is AI really good at, right? So it can look at all sorts of large amounts of data, really very, very multidimensional data, and kind of understand from that patterns that show up in this data. Right. So in some sense, if you think about humans, they really kind of struggle with that specific part, right? Because we don't really do well with, these high dimensions of data and trying to understand through that. But we have an ability to actually learn from very, very limited data, to look at totally novel situations that we've never been in before, right? And then just kind of make an inference or a connection from something else that we know. Even though if you look at it, it's like very hard to understand how did we make these type of connections, right? So if you think about, these are exactly the areas that AI struggles with today. So, and this is why we've seen it, kind of deploy in areas where, there is that humongous amount of crunching of data and surfacing insights out of that data. But we've also seen a lot of, focus and energy on trying to essentially replicate human capability, right? So you see, for example, all sorts of different games and, things where you could imagine all of these multiple turns into the future that you can analyze very quickly. The problem with that, though, I would say that despite the fact that it does well on these specific tasks, you take that same system and it wouldn't actually do well on a very minor task that maybe a 5-year-old can actually do. So I think that's kind of the big struggle with AI, is that's actually how does it generalize to new settings that it has not seen. So as a result, when we actually see it deployed in the real world, we take very specific tasks, we train it with a lot of data, and it can actually now, do inferences within that. And you try to ensure that you're not changing a lot of the settings or things that would make it actually be quite erroneous. Because if it starts to see things that it has not been trained for, you're going to see a huge drop in its performance.
And you referenced a few different case examples. I'd love to go deeper into some of those. You talked about the role that artificial intelligence can play in aiding childhood learning. Talk a bit about some of the work that's being done there, please.
Yeah, so this is actually a really interesting area. And it's funny because we kind of started working on this before COVID, and then COVID hit. And then, it's kind of, I think, amplified for everybody, how really younger kids were kind of left behind, right? So for older kids who had, all of the tools and available ways of, learning through content platforms and things like that, there's a huge impact from a social perspective, but at least from an academic perspective, many of those tools were there. Now, contrast that with what you see in early childhood learning, right? If you walk into a classroom for kindergartners, right, you don't see them actually working with PCs and doing that, right? You see them on the rug, on the floor, playing with objects, learning math, learning with their whole body, moving blocks around, understanding tens and ones and putting these things together. So to try to actually do that to actually bring that type of support and intelligence from an AI system to try to force them into a PC-like setup, right, isn't necessarily the natural thing to do. So part of what we've been really trying to do, and that came from a lot of ethnographic research that we've done actually with multiple stakeholders, with parents, with teachers, right? They're kind of struggling because they want essentially all of what technology can bring to the table, but they're terrified of screen time for a very good reason, right? So then what we really started working on is this notion of, can we bring the intelligence and the AI into the physical environment that the children are learning? So now imagine they're still working with manipulatives and trying to put tens and ones together and form their numbers and things like that. But they have an AI system that's kind of embodied in that physical environment that they're in, right? They're not seeing that thing behind the PC. It's actually conversing with them. It's watching them as they do these, put these tasks together, following with them. And it's kind of coming in as a peer learner, right? So we have this kind of like cute teddy bear thing, right? That actually kind of engages the kids, because we know ultimately from all of the pedagogy research that learning outcomes are really very much correlated with student engagement, right? So the more engaged they are in that physical task that they're doing, and then the AI system's kind of supporting it and it is in the environment, watching them do things, aiding them through steps, and sometimes kind of like, get between the physical and the digital, to make it actually more engaging and appealing. So that's kind of one concept that we've been really working on. We've deployed just before COVID in classrooms to test out these concepts. And now we're trying to take it actually into a home setting so that kids can, kind of practice what they learn and help, aid the teacher come into, to support the child through this, peer learner.
Fascinating. You also, in a past conversation you and I had, talked a bit about artificial intelligence role in helping adults with disabilities. I wonder if you can talk a bit about some of the examples there as well.
Sure. Yeah. So this work for us started, back in 2011. And that was actually working with Professor Stephen Hawking at the time, who, clearly suffered from ALS. Most people with ALS have this constraint, right? Because they basically can't speak and they can't move muscles, right, at all. So in very, very limited movement, right? So essentially, if you have this combined disability where you have, you can't actually communicate by speech and you can't type or do any of that, essentially you're locked out of most technology, right? So part of that idea was, okay, well, how can we bring technology to help essentially aid people in communicating by using whatever limited muscle movement that they have, and even if they don't, brain-computer interface, but then rely more on the AI system to try to understand much more of the context of that environment, right? So in the case of Stephen, for example, he would express his thoughts, and the AI was kind of limited to word prediction and learning from his previous communication to actually do better prediction. But if you think about like what we're really trying to do today with this kind of new version of that system is to have actually the PC listen to the conversation. So now, as the PC is listening into the conversation, it can start to generate suggestions at a much higher level, right? So rather than spelling letters and words, what you're actually doing is, you're highlighting higher level context, right? And you can show certain keywords that somebody can quickly select from, and it will generate a response for you. And, the person can choose that or can choose to actually then, specifically spell out something. And then the AI system will continue to learn as the person adjusts these things or chooses keywords, or even in free time, work with the AI system to say, hey, that previous suggestion that you made, I indicated that it wasn't, a great suggestion, but I'm going to choose it because then I can be spontaneous and respond quickly. But later when I have time, I can train the AI system of what would have been actually a perfect response for me to be, right? And so the AI system continued to evolve over time to really reflect better the kind of the way that the person speaks or their interests or even, what they would actually respond with.
Fascinating, really interesting progress that's been made there. I also wanted to, you alluded earlier to the use of AI in manufacturing. You talked about analyzing workflows and identifying unmet needs. Talk a bit about, I'd love to have you go a bit more into depth as to some of the things you're doing from that perspective.
Yeah. So if you think about, manufacturing settings, right? I mean, it's funny because we think of manufacturing as, okay, well, it's automated and everything. But actually, if you walk today to an Intel fab, yes, there is tons of automation in the things that are obvious, right? That humans don't add a lot of value to. But there are a lot of different tasks that really require that human capability, right? So, but you see people actually physically doing all sorts of tasks, right? Whether it's kind of like, fixing machines or repurposing things for specific products and things like that, right? And to be able to actually think through this, right? There's a whole workflow, right? If there's a spec, if you will, right? Where it's like, okay, this, to be able to move this machine from this product to this product, you would do all sorts of different things. And depending on what's going on, there's certain decisions that get made. But there is actually a specific sequence of tasks to it, right? So if you think there, what we see is, a lot of times there will be errors, there are different levels that people, have in terms of understanding. So you have novice, you have experts. So essentially you can think of an AI system that can come in and watch over people as they perform these tasks, right? The AI system can ingest all the information from the specs, understand all of these different steps, but now it needs to be able to match that to actually physically what it's seeing in the scene, right? And then it can recognize the different actions and sub-actions that are actually happening and follow along and bring all the relevant information to the person as they're actually doing the task. So either remind them that, okay, well, the next step is this, or you need this thing, or, oh, you missed a step, or this doesn't look like you've done it right. But actually, more interestingly, since it watches over experts and novices, right, it can learn from the expert and help train the novice. So it can actually start to highlight, it's like, okay, well, I've seen the experts kind of do it that way. Is this what you intended? And in some cases, what's interesting is that people start to change things off the spec. So it's also interesting to actually highlight things and say, okay, is it time to update your specs? Because it seems like most people are doing it in a different way, and that's resulting in better outcomes. So in some sense, the AI system is actually learning, and it's supporting the human, but it's also learning from the human. And we have this notion of being able to kind of walk along with the AI system. So as the AI system kind of learns a new task, the person can actually start to aid it by speaking to the AI system, and the AI system start to learn. It's like, okay, oh, that's what this task looks like, right? And okay, this is what the specific step looks like from a scene perspective, and it can continue to learn over time. So that's why we really think of it as a human AI collaboration. It's not just that the AI system knows it all and supports the people, because as I said earlier, part of the struggle is that the AI system usually only does well when it's seen something exactly the same way. But if you allow it to learn from the end user as they're performing the task and continue to learn, you kind of close the gap on this, how do we make it more robust in new environments and to support new tasks?
That's very interesting, Lama. Thank you for that overview. There are a lot of prominent technology leaders, Lama, who worry about AI advancing in potentially negative directions, whether intentionally or beyond human control. I know you're a big proponent of responsible AI. Talk a bit about what that entails and your vision for developing in a responsible AI fashion.
Yeah, and maybe I'll talk about two aspects of this. So one is what I was alluding to earlier around this notion of human AI collaboration, right? Because in some sense, you could look at this and say, there are multiple futures that we can go down, right? We could continue to try to think about how do we replace human capability, right? And how does the AI come to compete with human capability? Or we could say, and then you have all of the other worries from a societal perspective, right? As a result of that, right? This whole human AI competition and, all of the Hollywood, vision of the future, if you will. Or you could say, okay, well, let's recognize that humans and AI are very, very different. And as a result, what you really want to do is think of complete workflows and where best to bring the AI system and where best, to bring the person and make an outcome that's much better than either one of them alone. I mean, today, one of the things that we don't sometimes maybe think about is, yes, you could actually bring an AI system to go replicate a tiny piece of what a human can do, right? But it has a lot of limitations. But at what cost, right? At the cost of many, many cars on the road every time we retrain one of those networks to actually go do that work. So we have to look, more holistically, right? Resilience will become better when humans in the loop, you actually create better outcomes, from a long-term perspective, but it's actually much more also energy efficient as you think about it that way. So from a sustainability perspective, it makes perfect sense. So that I would say from a human AI collaboration, I think it addresses many of those gaps. The other thing that I would say in any type of AI development, I mean, one of the things that we know is that AI systems learn from tons of data, right? And this data, by definition, is quite biased. If you sample data from the real world without really paying attention to what data you're sampling, right, you see a lot of bias that just seeps into your AI systems because you've trained it with biased data. So part of what we think about, and at Intel, we have a lot of strong focus on that, is to think through how do you develop AI responsibly through the whole development lifecycle. Right? So how do you look at the risks in the context of the specific AI capability that you're developing and look at things like bias risks, look at privacy risks, right? I mean, it learns from tons of data. And as a result, we're constantly collecting tons of data to be able to train them. But are we actually thinking about it from a privacy constraint perspective? And are we making sure that there are all the right consents and the data is, data hygiene is there? We also look at this notion of transparency, right? You don't want to put a black box somewhere and allow it to make decisions on behalf of people, right? People need to understand, whether it's the developers or the end users or the regulators, they need to be able to understand why did the AI system make the decisions that it made. So thinking through that across the whole spectrum from a risk assessment perspective in the context of the project that you're working on, and then saying, okay, well, there's nothing without risk, clearly, but how do you mitigate that risk, right? On any of those areas that I mentioned, so that you're actually ensuring that you're developing AI responsibly throughout, the definition, development, and deployment lifecycle.
Really a great overview, very interesting vision you have there. I wanted to ask you here in conclusion, as you look to the future, Lama, as I mentioned earlier, and as certainly you've conveyed in great detail, so much progress has been made, but of course, there's still a tremendous amount of progress to be made to fully realize all that you've described. As you look out a few years, what are some of the trends that excite you most, some of the advances you anticipate perhaps reaching over the course of the medium term, so to say?
Yeah, I mean, I would say, on one area, I think if we think about this notion of human AI collaboration, we're starting to see some of these trends come up, right? Where people, because in some sense, it's much easier to say, give me tons of data. I'm going to just train, a network, put it out there, and then it will do something, right? It's much harder to think about how do you develop AI in collaboration with humans and think about all the different capabilities that need to come to bear to make that future possible. However, I believe that there are basic capabilities and building blocks that people can continue to build on, right? Not every single problem you're going to have to go and redesign this notion of how do you do human AI collaborative systems, right? The way that AI and humans can communicate and express and understand shared context that's shared in a physical environment, right? Many of those things have similarities irrespective of what specific domain you're deploying it in. So investing in that type of shared capabilities to really advance forward that work so that it's actually easier for people to then think through these collaborative systems to come to bear, I think that will make a tremendous improvement in this space. And we're starting to see some of these innovations happen on human AI interaction, for example, that actually helps with some of that. Also, I kind of touched on this sustainability problem, which is really a problem that worries me deeply, right? Because right now, if you think about the path that we're on, right, we can't just continue to do bigger and bigger and bigger, right? We have to start to think about how do we make these things not learn from scratch every single time. That's not how people learn, right? It's incremental in nature, right? So some of the advancements in incremental learning, in few shot learning from very minimal data, we're starting to see a lot of innovation in that space, and also learning at the edge with different types of structures. So for example, like neuromorphic computing is a good example, right? Where you can really learn with very, very power efficient ways, right, to continue to actually learn as the AI system is deployed in the world. So many of those, capabilities, whether they are in a human AI system or whether they're just a fully autonomous system, we start to kind of see different pieces of that puzzle come together to address these major gaps in general in the way that AI systems learn and continue to learn over time. So those are some of the things that I'm really excited about, because I think it will, we are starting to hit a wall with the energy efficiency. Even if you're able to do it from a compute perspective, do you really want to do it from a climate perspective?
Well, Lama Nachman, thank you so much for a stimulating conversation covering the remarkable work that you and your team are doing, the advances that you've made, as well as the advances that you see coming in the not too distant future. It's been great to speak with you today and wonderful to get your insights.
Thank you. Wonderful to speak to you, Peter.